Welcome to another class on motion graph. In today's class, we're going to go over velocity time graph, okay? Don't forget, in our previous class, we learned that velocity time graph is a graph showing the relationship between the velocity of an object and the time, okay? Let me quickly explain the three concepts that you have to understand, okay? We can have the velocity time graph of an object moving with a constant velocity. This is how the velocity time graph will look like. For an object that is moving with a constant velocity, that is, the velocity of that object is not changing, okay? This is how the velocity time graph will look like. You understand? That is, the object is moving with a constant velocity, okay? And this is time in seconds, okay? V in meter per second. Meter per second. For this, the object is moving at a constant velocity. Do you understand? Now, let's have another graph. Another graph that we're going to talk about is the velocity time graph for an object that is accelerating from rest. Okay? Now, if we are told that an object is accelerating from rest, this is how the velocity will look like because it is accelerating from rest. At rest, don't forget that on every graph we always have point zero. You understand? Point zero is here. Are you paying attention? Now, when the object accelerates from rest, then it changes position. You understand? Because acceleration causes an object to change position. Okay? So when the object accelerates from rest, we can say that the velocity of that object is increasing. Do you understand? Please pay attention. You are going to understand. Okay? So for the second graph, that is the velocity time graph for an object that is accelerating from rest. Okay? This is the rest. Then the object accelerates from point zero to another point. Okay? So here we have the velocity in meter per second, and here we have the time in seconds. You understand? This is the graph of a velocity of an velocity time graph for an object accelerating from rest. Okay? Now, the third graph that we're going to talk about is the velocity time graph of an object decelerating to rest. You understand? You know, the opposite of acceleration is deceleration or retardation. You understand? Retardation is negative acceleration. It is the kind of acceleration that brings the motion of an object to rest. Do you understand? So now, if a body, please, I want to pay attention. Let me check. Okay? Now, pay attention. If a body is decelerating to rest, this is how the velocity time graph will look like. We have velocity in meter per second, and we have time in seconds. Okay? If the body is decelerating to rest, that is, the body is already moving, has already accelerated, then moving, then it's decelerating. That means that the velocity is reducing. You understand? So now, this is how the graph will look like. You understand? That is, this is where the body is before. The body is traveling with a particular velocity before. Now, the body decelerates. That means that it changes position, and the position that it changes is what? Negative. That is negative acceleration. So this is how the graph will look like. Okay? So these are the three important things that you have to take note, because by the time we delve into work example, we're going to be talking about this kind of things. You understand? So please pay attention. This one is for a body that is moving with a constant velocity. You understand? Constant velocity. That is, the velocity is not changing. You can see that the distance is also straight. You understand? Now, we can see another one. This one is for a body that is accelerating from rest. The body is at rest before. Immediately, it accelerates, it changes position, and the height, it increases. And then, for the third one, we have the velocity time graph of a body decelerating to rest. Okay, now let's start with the first question. A body moving with uniform acceleration has 2.5, 15. Please pay attention. A body moving with uniform acceleration has 2.5, 15 and 20, 60 on the velocity time graph of its motion. We are asked to determine the uniform acceleration. Okay? Please, I want to pay attention. Let's start by let's draw the graph. Okay, let's draw the graph. We have this. We are given 2 points. The first point is 5, The first point is 5, 15. Sorry. And the second point The second point is 20, 60, 20, 60. Okay? Now, I want to pay attention. I'm very sure you learned about coordinate geometry. You understand? At every point, we always have x, y. You understand? X, y. That is x, y. And this also is what? X, y. That is, for the first point, x1 is what? X1 is, this is x1. Okay? And this is y. Okay? For the second point, this is what? X. And this is what? Y. Because on every point on the graph, we always have what? X, y. Do you understand? Okay? Now, let us plot this point on this graph. You understand? This will be what? X1. And this will be y1. This will be x2. And this will be y2. Do you understand? Okay? Now, for x1, let's say this is point 0, 0. Okay? Now, for x1, this is the x-axis. You understand? This is the x-axis and this is the y-axis. This is the x-axis. Now, for x1, we have 5. Of course, 5 is greater than 0. You understand? Let's say it is 0. This is where I'm going to have the x1. But the first coordinate for x1 is what? 5. You understand? Now, for y1, we have what? 15. So let me put 15 here. Please, are you paying attention? I'm just trying to plot the point. You understand? I'm just trying to plot the point. We are asked to calculate the acceleration for the uniform. We are asked to calculate the uniform acceleration. You understand? So I'm trying to plot the point on the graph because we are dealing with velocity time graph. Do you understand? So let's plot x2. X2 is 20. So let's say we're going to have 20 here. You understand? And y2 is 60. So we're going to have something like here 60. You understand? Now let us look. When x1 is 5, what is the value of y1? Y1 is 15. So let us trace it. Let us trace this also. So they meet at this place. So let us draw the point. And we raise this now. Are you paying attention? Please pay attention, okay? And then for the second point, which is 20, 16, x2 is 20 and y2 is 60. So let's draw the point again. Let me draw the point upward for the x2 now. Don't mind this thing. I'm not using graphs. You understand? Okay. And for y2, okay, this is where they meet. They meet at this place. Let's draw the point. You understand? Now we have plotted all the coordinates. You understand? Now we are asked to determine the acceleration. The acceleration of the uniform acceleration of velocity time graph is the slope. You understand? Don't forget, in our previous class, I told you slope is associated with what? Division. You understand? So, the uniform acceleration of a velocity time graph having 2 points is what? Is the slope. Do you understand? Now, the slope, let's draw the line. The line for the slope is here. You understand? So, we want to calculate the slope, okay? We want to calculate the slope. I just represent as AB. That's the line. Okay, now don't forget in your coordinate geometry, slope is always represented as what? N is equals to what? Y2 minus y1 all over x2 minus x1, or change in y all over change in x. Do you understand? I'm very sure you remember this formula very well. Okay, you are still going to use the formula to determine the uniform acceleration. You understand? So let's calculate the slope of AB. The slope of line AB is equals to change in x, change in y all over change in x. So I'm going to have y2 minus y1. Y2, please, I want to pay attention. Y2 minus y1 is what? Y2 is 60. You understand? So I'm going to have 60 minus y1. Y1 is 15. So 60 minus 15 all over change in x. Okay, let me erase this. All over change in x. Change in x is what? That will be 20, which is x2. Please pay attention. X2 minus x1. Okay, so 20 minus 15. 20 minus 5 rather. Now 60 minus 15, that is 45. Okay, so I'm going to have 45 whole over 15. So 45 divided by 15 is what? 3 is 3. And acceleration is measured in meter per second square. Do you understand? So I'm going to have 3 meter per second square. Do you understand? So that is the uniform acceleration. That's the uniform acceleration that we are asked to calculate. Now, please pay attention. On a velocity time graph, the uniform acceleration is equals to the gradient. That's the major point I want you to hold. Okay? On a velocity time graph, the uniform acceleration A is equals to the gradient or the slope. You understand? Or the gradient of the graph or the slope of the graph. You understand? The gradient is also the same thing as slope. Okay? So, question 2. A car starts from rest at a checkpoint A and comes to rest at the next checkpoint B, 6 kilometers away in 3 minutes. It has first a uniform acceleration for 40 seconds, then a constant speed, and is brought to rest with a uniform retardation after 20 seconds. Sketch a velocity time graph of the motion. That's the first question. Then we are asked to determine the maximum speed and the retardation. This is NECO 2003. Okay, please, I want to pay attention. This one is technical. Okay, so I want to pay attention. To watch the next class, kindly check the description of this video. You are going to see a link there. Click on that link, or you should check the playlist on this channel. Okay, see you in the next class.